Europe and Africa are closer than most people realize, so why has no bridge ever connected them? On paper, the distance looks manageable. It's shorter than many celebrated bridges and tunnels. The desire for such a link is undeniable. Yet despite centuries of proposals, the strait remains unbridged. This absence is not just politics or finance. The reason is far more fundamental. It's a story of geography defeating ambition. The real obstacle isn't the gap, it's what's underneath it. This is one of the most geologically active boundaries in the region. The answer is hidden beneath the map's surface. The number that truly begins to explain the problem is 900 meters. This is the maximum depth of the Strait of Gibraltar. Imagine constructing a bridge pier that is taller than the world's tallest skyscraper, but underwater, in total darkness. No bridge pier in history has ever been constructed at such a depth. The seafloor is not a gentle, sloping seabed, but a rugged, mountainous landscape submerged beneath the ocean. It is covered in thick layers of soft, unconsolidated sediment. Anchoring a multi-billion-dollar structure on that is like building a skyscraper on quicksand. This geological mess is known to engineers and geologists as a melange. It lacks the predictable, uniform characteristics of stable, continental crust. This inconsistency makes it nearly impossible to use standard tunneling techniques. The Strait of Gibraltar is not just a channel of water, it is a major tectonic plate boundary where the African plate is colliding with the Eurasian plate. The region is one of the most seismically active zones in the Western Mediterranean, with a long history of significant earthquakes. Any bridge or tunnel would have to be designed to withstand not just minor tremors, but also the major, once-in-a-century earthquakes that are known to occur. Designing a 14-kilometer-long structure to survive such an event, especially one founded in deep water on unstable ground, pushes the boundaries of what is considered possible. So if technology keeps advancing, will this ever be possible? The problem is not just the ground, but the water itself. The strait is a funnel for some of the most complex and powerful currents on the planet. This constant dynamic load would fatigue the structure over time, a relentless pressure that cannot be easily engineered away. Every solution works somewhere else, just not here. The channel tunnel was made possible by a thick, continuous layer of soft, impermeable rock. Even a floating bridge, typically used in sheltered fjords, would be subjected to unimaginable stresses from Atlantic storms and waves. A submerged tunnel creates an even greater concern. A collision with a submarine or a dragging ship anchor could be catastrophic. The most developed idea is a rail tunnel, but it would need to be far deeper and longer than any tunnel built to date to avoid the worst of the geology. The pressure inside the rock itself would be extreme, requiring unprecedented levels of structural reinforcement for the tunnel lining. Ventilation, emergency access, and evacuation for such a deep and long tunnel become critical, life-threatening constraints. Ideas exist. Reality hasn't agreed yet. In the end, we return to our starting point, the map. The absence of a bridge is not an indictment of our engineers or a lack of imagination. It is the result of careful scientific study and rational risk assessment. It is the wisdom of knowing when not to build. The unbridged Strait of Gibraltar is a powerful monument of a different kind. It is a monument to the forces that shaped our planet. Sometimes the absence of a bridge isn't a failure. It's the map telling us where the limits are. It reminds us that some gaps are, for now, unbridgeable.